Of the more than 600 people that have reached orbital space, less than half have performed a spacewalk. A commercial astronaut mission called Polaris Dawn, though, aims to add a few more to that list.
It's been 2.5 years since we announced the Polaris program and Polaris Dawn. It's been a really exciting journey of development and training.
Entrepreneur Jared Isaacman is the mission commander. He's making his return to space after first leading the crew of Inspiration 4, the first entirely commercial astronaut mission, back in 2021. He and his Polaris Dawn crew will fly that same Dragon, tail number C207, nicknamed Resilience, through their 5-day mission.
We spent the last 2.5 years together really becoming a family as we got ready for this mission. Now, we all have very interesting ties back to Inspiration 4. In the case of the kid, even prior to that, we built a lot of trust during that mission. I think that allowed us to really hit the ground running, and in combination with all the great people at SpaceX, really accomplished a lot over the last 2.5 years.
Before the crew arrived at the Kennedy Space Center on August 19th, Spaceflight now spoke with each of them, one-on-one, to learn more about their own journey to the mission and what they're bringing to the table.
I remember in kindergarten taking home all these color-like picture books of the space shuttle. And I was just totally enamored with space. I wanted to go to space camp. You know, Nickelodeon, all the commercials were about space camp, it felt like. So I don't know, it was there. I definitely at some point, and I don't know if it was my parents or otherwise, just someone telling me, hey, it's odds aren't great. Every kid wants to be an astronaut. And I kind of gravitated more towards the aviation track, thinking it was as good as it was going to get. And it is great. Fortunately, times change, and now, the dream of going to space in like a commercial capacity is real.
That dream became a reality when Isaacman, the founder and CEO of Shift4 Payments, bankrolled the Inspiration 4 mission, designed in part as a fundraiser for St. Jude Children's Research Hospital. Similarly, mission specialist Menon says it was a 4th grade field trip to the Johnson Space Center in Houston, Texas, that sparked her imagination when it came to space.
We got to experience a day in the life of an astronaut as well as a flight controller in mission control. They split us up as a class, and each one of us took on a part of the team, both in mission control and the astronauts on the space vehicle. And then we flew the mission together. And then later in the day, we swapped sides and played the opposite role.
That glimpse into mission control operations led Menon to spend 7 years as a flight controller herself at NASA.
I served to help our astronauts on the International Space Station by supporting the medical hardware and software that they used. That means that, my goal was to help keep them safe and healthy and have a successful mission at the end of the day. I was able to really lean on this background when I moved to SpaceX. My job at SpaceX has been to work in crew operations development. That means that I, with my team, help put together all of the different operations that our astronauts do in our spacecrafts. I try to put myself in their shoes and think through, how do we use our hardware and software, everything available to us in the spacecraft, to fly, to do everything we need to do in space safely and successfully. That is everything from how do you put on your spacesuit in space to how do you respond to an emergency such as a fire or rapid depressurization.
One of those astronauts may be her husband, NASA astronaut Anil Menon. She says being open with her family has been an important part of preparing for her first mission to space.
Our family believes in open communication, and so we talk with our kids. My husband and I have really open communication about all of the details of the mission and how we are preparing. I have sat down with my kids and talked them through like what the time leading up to launch will look like, what the mission will look like, how mommy will come back down, splash down and give them a big hug, and try to help them wrap their heads around the details that will be coming into their lives soon. And then my husband and I also really have, the great joy and privilege of sharing this love for space together. We've worked side by side through so many chapters of our careers together, and I feel so privileged to get to share this journey with him too. And so, we continue to talk about everything going on and, work hard as a family to make sure that everyone is ready, both mentally and physically, for the journey ahead.
Menon is joined on the Polaris Dawn mission by fellow SpaceXer and mission specialist Sarah Gillis. But unlike Menon, space wasn't always at the core of Gillis' life.
I was not raised as an engineer. I was actually raised as a musician. And it wasn't until high school when I met former NASA astronaut Joe Tanner, who was a professor of engineering at University of Colorado Boulder at the time. And my brother actually had an engineering or a science for non-science majors course where Joe was a guest lecturer. And I went with him to that course and started talking with Joe afterwards. And I had to put together a senior project, and Joe actually was very kind and gave me his contact information, and went out asking if anybody was looking for a high school intern type concept that I could work with someone. And he came back and said nobody was interested, but that he was totally willing to help me put together a project.
Gillis ended up as a student at CU Boulder as an aerospace engineering major. As a full circle moment, she'll be working on 2 experiments from the university as part of the Polaris Dawn mission. One of them is called Triggerfish.
This contact actually has an integrated pressure transducer in it. And so when we put them in our eye, we're able to get a continuous readout of intraocular pressure. Historically on ISS missions or on spaceflight missions, they're capturing that data, but they're using a pressure probe that contacts the eye and gives you a single data point. So there's not like a history or a look over time at what's actually happening with pressure in the eye. So this should be a really interesting look at how our intraocular pressure changes shortly after we arrive on orbit, and kind of what process happens from the intraocular pressure perspective as we're adjusting to the microgravity environment. So it should be pretty interesting to see what comes out of that, but they look really fun. They kind of look like a cyborg eye, so we have a lot of fun when we put them on.
Along for the science and other aspects of the Polaris Dawn mission is Scott "Kid" Poteet. He's a retired U.S. Air Force lieutenant colonel with more than 20 years of service and 3,200 flying hours. Poteet works alongside Isaacman as the vice president of strategy at Shift4 and was the mission director for the Inspiration 4 mission. He's also an elite runner who completed 15 Ironman races and will do his 16th this fall.
It's just part of my life. My wife runs. We like to spend a lot of time together running. We've kind of passed it along to our kids who are big runners. And I really think it's important for spaceflight. Going into that type of environment is not easy. It's very austere. There's a lot of changes to the body that you experience when you get to microgravity. And that's where we've kind of focused a lot of our science and research, is to be able to see how the body handles the microgravity, the weightlessness. You're not using your muscles, your tendons, your ligaments like you typically do on Earth. And if we're going to start extending durations of these space exploration missions, you talk about going to Mars, it's 8+ months to get there, the duration you're going to spend there, and then the return trip. That's longer than any human has been in space. So we got to solve some of these challenges, and that's what Polaris Dawn is all about.
Poteet openly acknowledges that he doesn't have the spaceflight experience of Isaacman or the SpaceX knowledge that Menon and Gillis bring to the table, but he says his time in the Air Force gives him a good operational background that complements his crewmates.
I'm very thankful for that background. It provides me an opportunity to have the skill sets necessary to be able to handle, contingencies on space. So, we fly fighter jets, and that is a good training tool for us to prepare for space. It's us working together as a team in a fairly risky environment, working through contingencies, working through checklist procedures. Communication is challenging, with the mask you're wearing and talking to different agencies and formations. So those are all skill sets that I've been able to help train our crew with. And then on the flip side, they've helped me learn the systems of Dragon and the Falcon 9 rocket and get me up to speed so we can take on these more challenging objectives.
They're putting all of their individual skills and backgrounds together for a mission that will last a little more than 5 days. In addition to lots of science, the crew will be hitting a few big objectives. One of those includes going further than astronauts have traveled since the Apollo days and exposing themselves to the Van Allen radiation belts.
If you are moving into the unknown, you are going to have to take some risks because there are unknowns. But fortunately, there's a lot of smart people between NASA and SpaceX that have done the analysis, that have done the testing, that gives us comfort that we can take steps in the directions that we are with Polaris Dawn in a, in as safe a way as possible.
Isaacman and his team spent the past 2 years doing extensive training, which included going to extremes like mountain climbing, scuba diving, and flying jets. He says the Starlink technology demonstration they'll perform was a big driver of the timeline to launch.
This is kind of one of the benefits of our mission taking 2+ years to get to this point. And you'd think a lot of it was the suit development, which it was, but a lot of it was the Starlink program as well. It has become more and more integrated into the vehicle. So initially, it was a very scrappy approach to test Starlink. The actual laser, the laser link is built into the trunk. So they went through all of the analysis associated with that to ensure it was safe throughout all phases of flight, including a launch abort. And then they've already, what's installed in our trunk is already obsolete in good SpaceX form. There's several other generations ahead of it. And it has been integrated into the avionics and systems of the vehicle, so that at some point in time you are able to use it as a primary method of communication for telemetry, commanding of the vehicle, and such.
However, the part of the mission that has understandably taken center stage is the first commercial spacewalk in history.
Dragon, SpaceX, successful leak checks. Dragon has initiated cabin venting.
It will be performed on the 3rd day of the mission, with the entire Dragon capsule being brought down to vacuum. Isaacman and Gillis will each exit the vehicle, one at a time, with the help of a hand and foot railing apparatus called the Skywalker, as seen in this animation.
Primary objective for sure is about the suit, to inform suit design changes. Secondary objective is the operations itself and what we can learn to improve upon it for the future. Ideally, working into a no pre-breathe state where people could truly put on a suit and exit a vehicle very, very quickly, as opposed to this, we have a multi-day pre-breathe, for example, on Polaris Dawn.
Gillis spent much of her time at SpaceX working on the Crew Dragon in its original form. She says taking the next step on behalf of the company means a lot to her.
It's been so cool over the last 2 years to almost start that process again. Like, it's a different development program where we're adding an entire nitrogen repress system into the spacecraft. We have to make sure there are the right mobility aids to support a crew member performing the EVA. It's been really, really cool and really special for me, given my context on why the Dragon is the way it is. But now getting to actually help develop a brand new spacesuit and test how it integrates into the spacecraft and how it actually can support a spacewalk. So that's been something that's really, really cool for me to participate in the last 2 years. But I think most interestingly is then, what is that actually like in space? It's end to end. We started from design concept through to actually experiencing that on orbit. And so I'm really, really interested to see what we learn doing the EVA, what ways we need to modify our training for future spacewalks. But it should be really interesting to see that full design evolution come together.
Some of the training for the spacewalk involved developing special harnesses to simulate microgravity during movement both in and out of the Dragon training capsule. They also spent 2 days in a vacuum chamber at NASA's Johnson Space Center in order to validate the pre-breathe protocols they developed for the mission. Some of the final suit training came when they went back to the Johnson Space Center in July in order to do more testing with the final version of the suits in an historic vacuum chamber.
I think you feel the same as you do the entire journey preparing for this mission. Is like, you're just so fortunate to be able to be a fly on the wall, to all the history being made around you. And I really mean that. It's no different than, the Mercury, the Gemini, the Apollo astronauts who used these chambers, which is they were one component of an army of hundreds of thousands of people then, tens of thousands now in our case, that go into making this possible. So you just feel really fortunate to even be there. And you try and make the most of it. Then there's probably a few hundred people that have prepared for months, literally, for the vacuum chamber runs that we just did. And we just got to make the most of all their efforts, get good data out of it, and, be willing to do whatever it takes to make sure it was a worthwhile effort.
As he and his team make final preparations for the mission, Isaacman says this first chapter in the Polaris program has been an emotional roller coaster.
it's interesting. There's a lot of emotions, I'd say, going into this. I mean, for sure, there's just tons of excitement, enthusiasm, because you know you're in the home stretch, and every day you're checking off another important box, another major milestone is complete. I mean, just yesterday, Kid and I were, in the vacuum chamber. It was a 7-hour operation to give, final confidence in our suits, going into the launch, and that's a major milestone that's now, getting completed. So it's going to happen, and it's approaching. The other side, which makes it very bittersweet, is that this has been my family for more than 2.5 years, and I know what it's like when the mission comes to an end. You've reached this incredible high, and then it's kind of over. Now the friendships, the relationships never end. I mean, you have a bond like you wouldn't believe, but it goes from a very big high to a low. So I'm trying to share that experience with my crew of we got to make the most of every bit of these last couple weeks, and all the memories associated with it, because this incredible journey we've been on is coming to an end. Now it comes to an end in a pretty incredible way. This is what we've trained for, but yeah, there is some bittersweet elements to it.
Reporting for Spaceflight Now, I'm Will Robinson Smith.